Hello, all. Thank you for being in touch again. We thank God for another opportunity to go through a lecture. Let's have a short prayer as we start. Heavenly Father, we bless you this day for your goodness upon us. Thank you for your love, the blessings that you bestowed upon us. Thank you. We pray that as we go through this lecture, you guide us through and help us to fully comprehend what we have to learn. In Jesus' name, I pray. Amen. Thank you very much. Right, so we are looking at simulation, and so we're looking at system modeling and simulation. And today we're going to look at the simulation of queuing systems. All right, so when we talk about queuing system, it's all about um, a channel where we have a calling population, and of course we are looking at the single channel queuing system. So we have a calling population, which are the many people who are there to be served, and they are there. Some come to be served. So as they join the queue to be served, or as they enter into the system, we see that this population enter at random. Don't know when they will come. So any of them could come at any time. So when they come in and there's customers in there to be served, they have to join the queue. So they join the queue and have to wait to be served. So we have the queue in which they will be waiting, and then the time that they will wait for them to be served depends on the customers that are available at the time that they arrive. All right, and then the serving is done by a single server. So that is why it's called a single channel queuing system. So it's only a single server that is there, and he'll be serving all these customers that are coming in. And as the customers are served, they go back to join the calling population. So we are going to look at a typical example of that. All right, so this example says that a small grocery store has only one checkout counter. Customers arrive at this checkout counter at random from 1 to 8 minutes apart. Each possible value of inter-arrival time has the same probability of occurrence. The service times vary from 1 to 6 minutes, with the probabilities shown in table 1. The problem is to analyze the system by simulating the arrival and service of 6 customers. Using the sequence of random numbers in table 2, determine the following. So we have table 1 here, which gives us the distribution, probability distribution of the service time. And then the random numbers have been given to us, the range of random numbers. So we have random numbers for arrival and then that for service time. We have to determine the average waiting time for a customer. So as a customer enters the system, what is the average waiting time per this information that we have here? The probability that a customer has to wait in the queue. the fraction of idle time of the server, the average service time, the average time between arrivals, the average waiting time of those who wait, the average time a customer spends in the system. So the essence of all this is to help the system or the management of such a store to be able to plan. So when they're able to see that, oh, their customers wait for too long here when they come to buy things, then they find a way of optimizing their services to make it better. So in order to determine all this, they have to be able to simulate, to analyze and determine this information to help for planning purposes. All right, so let's go into it. So the first thing we have to do is to draw the arrival and service timetables and obtain random number assignments. All right, so first of all, we need to um, draw the arrival and service time table. If you come here, let's go back, let's read through again. It says customers arrive at this checkout counter at random from 1 to 8 minutes apart. All right, 1 to 8 minutes apart. Each possible value of inter-arrival time has the same probability of occurrence. So customers arrive from 1 to 8 minutes apart, and each of them has the same probability of occurrence, which means that from this 1 to 8 minutes of arrival, random arrival, each is having the probability of the same probability, which is going to be 1 divided by 8, 1 over 8. So 1 over 8 means that first what we do is to draw the distribution of time between arrival, distribution of um, time between arrival. So we have the time from 1 to 8 minutes. That is a inter-arrival time distribution. Then the probability of occurrence of these arrival times, inter-arrival times, is each going to be 1 divided by 8 because they all have the same probability of occurrence. So we have 1 over 8, which is 0.125, 0.125, 0.125 throughout the same. Then when we have this, we'll produce what we call the cumulative probability, which means that we are mainly going to add up this. So the first one we have 0.125 plus this one, which is going to be 0.250 plus this one, that is 0.375 plus that we have this one, and you continue until the end. So you see that when we add everything up, we're going to get 1 when we add everything up. So the final one, so cumulatively we add it up, and the sum is a summation of all will end at 1. All right, then we assign the random digits, if you look at the random numbers that we have been given, we have random numbers from this to that. And if we are going to assign random numbers here, we're going to determine the first one falls. You can say that the first one is 0.125. So we start any number from 0.001 to the 0.125. Then at the back of that, the next level, we have 126 to 250. 126 to 250. All right, then 251 to 371 and 375, and then 376 to 500, 501 to 625. Then we have here 751 to that, then finally 876 to 1000. but we want to maintain only three digits. All right, so we use 00 without bringing the 1, so we end here. So that gives us the distribution of time between arrival table. Then we also um, draw a table for the service time distribution. So service time distribution, we're already given the probability of occurrence given to us here. So we have 6 customers, and then the service time in minutes for customer 1, customer 2, customer 3, 4, 5, 6. The probability has been given to us here. All right, so we have the service time here: 1, 2, 3, 4, 5, 6. The probability that a customer is served in 1 minute is that. Probability that a customer is served in 2 minutes is that, up to this value over there. All right, so we have the probability distribution here, and then the service time in minutes here, up to 6 minutes. All right, then we have the cumulative probability again. So similar to what we did earlier, going to add up. So we have from 1 here, then this level is going to be 1 plus 2, that is 3. 3 plus 3, 0.06. 0.06 plus 0.025, we have 0.085. 0.085 plus 0.01. 0.0195. 0.095 plus 0.05, we have 1.00. The random number assignment, so here it's going to be from 0 to 0, 1 to 10, and then 11 to 30, 31 to 60, 61 to 85, 86 to 95, 95 to 100. Then the next thing we do is to determine the time between arrival and service time, and the service time. So we'll draw another table, which is the time between arrival table and the service time table, and we do that, and then we're able to assign the random numbers here. So first, we have 6 customers in the system that we are to analyze. So we have the first customer 1, customer 2, customer 3, customer 4, customer 5, customer 6. And if you look at the table, the random number table or random digit table, there is a dash in the first column here. So we have random numbers 1, 2, 3, 4, 5. 5 random numbers. And the reason is that the first customer do not have to, there's no inter-arrival time because there's no other customer in the system. So it comes in at no time, so that is 0. So it comes in when there is no other customer there, so there's no time between the arrival of another customer before this customer. So we put dash dash there, so we don't assign any random number to it. So the second customer, the second customer comes in, and then the random number assigned to it in this case is 913. So that is the first one. So we have 913, 727, 15, 948, 309. So it follows in that order to the end. Now we are going to assign the random number. So when you pick the first one, this is dash, that there is no interval time here, so the random digit we assign to it is nil. Then time between arrival is nil. So the random number, the first one here, that is for customer 2, is 913. So when you pick 913, you come to the time between arrival table. Then you look for that random digit, the range where it falls. So 913, we can say that it falls between 8762 thousand, which means that in that case the time between arrival for customer 2 is 8. So we pick 8 and we write that here. The next one, customer 3, is 727. 727 is over here. Sorry, is over here. All right. So if 727 is here, the interarrival time for that customer is 6, the time between arrival, which means that after customer 2 have arrived, it took 6 minutes for customer 3 to also arrive. Then customer 4 is 15. 15 is from 001 to 125. So that means that the time between arrival is 1. So we put 1 here. Then the next one is 948. 948 for customer 5. 948, we can locate it somewhere here, and we can say that again the time between arrival is 8. So write 8 here. The next one, 309. 309, we can locate it somewhere here. So the time between arrival is 3. So put a 3 down here. After that, we also draw the service time table and assign the random digit. Then we are able to determine the service time in minutes. So the service time table, we have 6 customers. So we have 1, 2, 3, 4, 5, 6. Then we assign the random numbers here. So random numbers start from 84, 10 that up to this value 79. So we'll come here, we have 84, 10, 74, 53, 17, 79. Those are the random digits. So customer 1, this is the random digit for it, customer 2 up to customer 6. So we'll pick 84. We come to the service time distribution table, then we locate 84 within the random digits. So random digits here, 84 is over here, all right, between 61 to 85. So at that point, we can determine that the service time for that particular digit is 4. So we write 4. Right, so the time that the system takes to serve customer 1 is 4 minutes. Then the next digit is 10. 10 is located here. Right, so we have the service time to be 1. So we write the 1 here as the service time. 74 is located over here. So the service time is 4. So we have 4 here. 53 is located here, and the service time is 3. So we write 3. 17 is located here. So we have the service time to be 2. And then 79, the is located over here. So the service time is 4. So we have 4 here. So we have determined that. The next thing is to move to the simulation table. So on the simulation table, we are now going to simulate and be able to determine what is required, or the information that we need. Right, so on this simulation table, we are going to determine the arrival time. We have to determine the time service begins, the time customer waits in the queue, the time service ends, and then the time customer spends in the system, and also the idle time for the server. Right, the ideal time for the server, and we need all this information to be able to correctly analyze the system. Okay, so first we draw this table, and we draw the table. We have the column for customers. So we have customers 1, 2, 3, 4, 5, 6. Then we have the time since last arrival. Time since last arrival. So time since last arrival, we have the information over here. So this is the time between arrival. So first, the customer one came in when there was nobody, no one in the system, and nobody have arrived before customer one. So that is zero. There's nothing there. The customer 2 came in 8 minutes after customer 1 has arrived. Customer 6 came in 6 minutes after customer 2 have arrived. And customer 4 came in 1 minute after customer 3 have arrived. And in that order. Alright. So the time between arrivals will start from the dash customer 1 came in when nobody have come into the system. So we have dash there, then it follows 86183 as we have on the other table, as we have on this table here. Then the next column is the arrival time, which we will have to calculate from the simulation table. The next one is the service time, which is in minutes, the service time. And the service time is over here. That one we have it on this table here. So that one we have determined. We have 6 customers, and the service time is here. So the time the server took to serve customer 1 is 4 minutes. The time it took to serve customer, say customer 4, is 3 minutes, and it followed in that order. So it means that over here we have to put them here. So customer 1, the service time for customer 1 is 4, customer 2 1, customer 3 4, customer 4 is 3, customer 5 is 2, customer 6 is 4. All right. So those are the informations we have already. Now the rest we need to calculate them. So first we have to determine the arrival time. Let's take customer 1 for instance. Customer 1 came into the system. So that is the first customer that is coming to the system, and there is no time difference over there. So it just came at time 0. So we have the arrival time for customer 1 is 0. All right. And we come to the time service begins. Time service begins. Customer 1 arrived in when there's nobody have arrived. So the time that is beginning is time 0. All right. The time the customer waits in the queue. The time the customer waits in the queue is 0, because when customer 1 came in, the server is there. It's not doing anything. It's just idle. All right. So the time the customer waits in the system is 0. So he came in and instantly the server started attending to him. Then the time service ends. So service will end at time 4, because the service took 4 minutes to be done, and customer came in at time 0, and he spends 4 minutes. The server spends 4 minutes to serve the customer. So the time the service ends, it will be at time 4. Right. Then the time the customer spends in the system, the customer spends only 4 minutes in the system, and is gone because he came in, didn't have to wait. There's nobody there, only the server. Just was attended to, and it's gone. The idle time of the server is 0. Idle time of the server is 0 because we are beginning. So from start, customer 1 came in and was serving, is gone. So no idle time for um the server at that point in time. Okay, now let's go to the second one. Customer 2. Customer 2 arrived at the system in 8 minutes. 8 minutes after customer 1 have arrived. All right. So The arrival time for customer 2 is 8. The service time is 1. That we have determined that already. Then the time that the service begins is 8, because by the time that customer 2 came into the system, customer 4 is already gone. It's not there. So the server is there, just waiting. So the time that service begins is 8. So as soon as customer 2 arrived, the service started. All right. Then the customer waits in this queue is 0, because when customer 2 came in, there was nobody there being served. So the customer 2 didn't have to wait at all. The server attended to customer 2 instantly. So there's no waiting time for the customer in the queue. Then the time service ends. So the time service ends here is going to be the time service begin, all right, plus the service time. So the service time is 1, and the time the service began is 8. So that will give us 9. When we add 8 plus 1 is 9. Then the time customer spends in system, the time the customer spends in system is going to be 1. All right, that is 1 minute. He came in at time 8 and he was instantly attended to in 1 minute. So that is 1. Then the idle time for the server. The idle time for the server is going to be the difference between the time that customer 1 left. All right, the difference between the time customer 1 left and then the time that customer 2 came in. So customer 1 left at time, the service ends at time 4, and customer 1 is gone. So the server have to wait, sit and wait. It has to be idle, right? Sit and wait for 4 minutes before customer 8 arrives, all right? Because the arrival time for customer 8 is 8 minutes, but in 4 minutes from the beginning, customer 1 is gone. So it will take 4 minutes before customer 2 arrives. So when customer 2 arrives, at that time the server has been idle for 4 minutes. So it's going to be the 8, that is the time that the service started for customer, the time that the service began for customer 2 minus the time that customer 1 left the system, that is 4. All right, the next one is customer 3. So customer 3 came in 6 minutes after customer 8 have arrived. 6 minutes after customer 8 have arrived. So the arrival time from the beginning is going to be 14. That will be 6 plus 8. That is 14. That is the arrival time. The service time for customer 3, we know that one to be 4. Then the time service begins for customer 3 is going to be 14. All right, because the time that it came in, customer 3 came in, there's nobody in the system. Customer 2 is already gone. So we have the beginning time to be 14. There's no queue because when customer 3 came in, nobody is there being served. So instantly the server started attending to customer 3. Then we come to the time service end. So the service ends at 18, and that is going to be the time customer 3, the time the service began for customer 3 plus the service time. So service time, the time taken to serve customer 3 plus the time they started serving customer 3 is going to be 18. That will be the time that the service ends. All right. Then the time customer spent in the system is also 4 minutes because he came in, nobody was there, and the server attended to him in 4 minutes. So that is the time spent in the system. Then the idle time, the idle time for the server, the idle time for the server this time is going to be 5. All right, because customer 2 have left the system at time 9, and then in time 14 customer 3 came in. So 14 minus 9, that gives us what? 5. All right, so that is the idle time. So for 5 minutes the server was waiting until the customer 3 came into the system. Now let's go to the fourth customer. So first customer, the inter-arrival time is 1. So customer 4 arrived 1 minute after customer 3. All right. Then the arrival time for customer 1 is therefore going to be 14 plus 1. That is 15. Then the service time for customer 1, we know that to be 3. The time service begins, the time service begins is going to be the time that customer 3 left the system. So customer 3 left the system at 18, but customer 4 has been in the system at 15. So it has to be there and wait for customer 3 to leave. As soon as customer 3 leaves, the server started attending to customer 4. Right, so the service begins at 18. Then the waiting time. So this time, because customer 4 has been in the system at time 15, and at time 15 customer 2 is being attended to, all right, so it has to wait for 3 minutes. 3 minutes, so it's going to be 18 minus 15, that is 3. So after 3 minutes, then customer 3 is gone, then they could attend to customer 4. So the waiting time is 3 minutes. Then the time service ends is going to be 18 plus 3 because it took 3 minutes to serve customer 4. So that 18 when the service started plus 3, that is 21. That is the time the service ends for customer 4. Then the time customer spends in the system. The time the customer spends in the system, right? The customer came to the system at time 15 and left the system at time 21. So it's going to be 21 minus 15, that gives us 6. That is the time the customer spent in the system. Then the next one is the idle time for the server. This server will say that has no idle time because the time that customer 4 arrived, all right, customer 3 is being served, and soon as customer 3 soon as the server finished serving customer 3, customer 4 entered to be served as well. So the server doesn't have idle time here, so that is 0. Right, now let's go to the next one. Customer 5 came in 8 minutes after customer 4 entered the system. So the arrival time is going to be 15 plus 8, which is 23. We know the service time for customer 4 to be 2. The time service begins for customer uh, 5 is 23. All right, 23. That is when customer 5 has arrived at time 23. But the time it arrived, customer 4 has already gone. He left at 21. So 23 is the time that service begins for customer 3. Then the time that the customer waits in the line is 0. Doesn't have to wait in the queue. But when it came in, the server was free. Then the time service ends. So time service ends is going to be 23 plus 2, which is 25. All right. Then we have the time customer spends in the system. The customer spends in the system 2 minutes in the system. He did not wait, and the server took 2 minutes to serve the customer. The idle time for the server, idle time of the server is going to be 2, and that 2 is the time customer 4 left the system, the difference between the time customer 3 entered, all right, and then when customer 4 left the system. So that is going to be 23 minus 21, which is 2. That is the ideal time for the server. Customer 6 came in 3 minutes after customer 5 has entered the system. So he arrives at time 23 plus 3, which is 26. The service time for customer 6, we know it to be 4. Then the time service begins is going to be um, in this case 26. All right, because the service for 20 the service for customer 5 ended at 25. So when customer 6 came in, the server started attending to him directly. So we have the time that it starts to be 26. That is the time that the arrival time is the time that service uh, begins for customer 6. Customer 6 did not wait in the system, so we have 0 waiting time. Then the time service ends is going to be 26 plus 4, which is 30. Then the time the customer spends in the system is going to be 4. So customer 6 spends only 4 minutes. That is the time taken to serve. There's no waiting there. Then the idle time of server is 1, because when customer 5 left, he left at time 25, and then customer 6 entered at time 26. All right, so 26 minus 25, that gives us 1. That is the ideal time for the customer. The ideal time for customer for the server. All right, before customer 6 entered, the server was idle for 1 minute. So we have the time customer 6 arrived, 26, all right, minus the time customer 5 left the system. That gives us 1. All right, now when we are finished, we'll have to total. So we'll total first of all the service time in minutes, right? The service time in minutes. So the total service time is 18. We also add the time customer waits in the queue is 3. The time customer spends in the system, when we add everything, is 21. The idle time of server, when we add everything, is 12. So now let's come to the questions now. We are to determine the average waiting time for a customer. The average waiting time for a customer is equal to the total waiting time divided by the number of customers. All right, the total waiting time divided by number of customers. The total waiting time of customers, we have added it to be equal to 3. The number of customers is 6. So 3 divided by 6, that is 0.5 minutes. That is the average waiting time of a customer. The probability that a customer has to wait in the queue, the probability that a customer has to wait in the queue, and that is given by the total number of customers who waited or who wait, right, divided by the number of customers. So how many customers waited in the queue? When we check the waiting, the time customer waits column, we see that it's only one customer that waited in the queue, which is customer 4. So in that case, when we use this formula, it's going to be 1 divided by 6. Only one customer, so 1 divided by 6. That is going to be 0.167, or we can say that is 16.7%. All right. Then the fraction of idle time of the server. Fraction of idle time of the server is equal to the total idle time of the server divided by the total time of the simulation. The total time of the simulation. All right, so the total time of the simulation in this case is 30. So the service, all the services ended by 30. Everything has ended. So that is 30 there. All right. The total time of the simulation is 30. Then the total idle time of the server is 12. So we're going to have 12 divided by 30, which is equal to 0.4. All right. So this one we can say that it means is, we can also put it in other ways, the probability that the server will be idle or the server is idle, and that is going to be 0.4, or we can say it's equal to 40%. All right. The average service time is equal to the total service time divided by the number of customers. So the total service time, we added everything, and we are getting 18 divided by the number of customers, 6, and that gives us 3 minutes. The average time between arrivals is equal to sum of time between arrivals divided by number of arrivals minus 1, divided by number of arrivals minus 1. So sum of time between arrivals is equal to 26. Right? When we sum up the time between arrivals, all this up to that, we get 26, that value, divided by 6 minus 1. We make it 6 minus 1 because there is no time between arrivals for customer 1, so that is nil. So we are going to have 1, 2, 3, 4, 5. So we have 5. So it's going to be, this 26 is just the addition of these 5 customers. So it's going to be 26 divided by 6 minus 1, which is equal to 5.2 minutes. The average waiting time of those who wait. So those who wait in the system, the average waiting time is equal to total waiting time divided by number of customers who waited. So let's see that here, number of customers who waited in the system, they are 3 customers. All right. And the total waiting time, sorry, it's only one customer who waited, and then the total waiting time is 3. So we are going to have the average waiting time of those who wait to be equal to 3 divided by 1, which is 3 minutes. Then the last one, the average time a customer spends in the system, and that is equal to the total time customer spends in the system divided by number of customers. All right, so the total time customers spend in the system, is 21. So time customers spend in the system, we add everything, we get 21 divided by the total number of customers, which is 6. So 21 divided by 6, we get 3.5. 5. Thank you very much. We end here. In case you have any question, you can post it. Thank you. So based on this information, the um, company or the store can take decisions. God bless you. See you next time.